Hey folks! So today, before we launch into the actual lesson, I just want to take a quick second and make note of the notes frame that we're using. It's a notes frame called Cornell Notes, and we notice here that we start out with a purpose, and we have the notes in this middle section, and this off to the side are the cues. Now the cues column is kind of like your little place to write down any notes, because I'm going to use teacher speak in the notes. But if you find a better way for you to understand or a better way for you to explain for yourself, just write little notes for yourself in the cues column. And at the end of the notes, what I want everybody to do at the end is just write the summary. So summarize what you've learned. It's a really good way to kind of concentrate. It's a really great way to summarize, for a lack of better word. Summarize and solidify. Also, let me know what you think. I'm using a different microphone. Is this making a difference? Thanks, Will. Okay, let's launch into it. So, in this spot right here, we're going to write our names. For me, it's Tara. There's the W. And the purpose. The purpose I will always give to you because it helps to set the notes up. So 1.1, classifying numbers. Now, in a lot of ways, this video is going to be one of the most boring on earth because all it is going through a whole bunch of definitions, writing them down, and then sorting a few numbers, making a visual. But you know, it's important to have definitions. So let's do this. Natural numbers are the numbers that we count with. They are they're numbers such as 1, 2, 3, etc. Everything from 1 to whatever biggest number that you can think of, that's actually a number, not a concept like infinity, is included in the natural numbers. So you'll notice that 0 is not in the natural numbers, neither are negative numbers. Whole numbers, it's the same thing as natural numbers, but we just add 0. Actually, I'm not going to put that there. That's the null set, so we'll just say 0. They're all going to be positive. And 0, which is neither positive nor negative. So 0, 1, 2, 3. So integers are all negative and positive whole numbers. So we start at like negative, you know, the biggest, littlest number you can think of. So in this case, I'm just going to say up to 3, -2, -1, 0, 1, 2, 3, all the way up to the biggest number, biggest positive number that you can think of. Now, rational numbers are numbers, and we'll come back to this definition again in the next lesson, but rational numbers are numbers that can be expressed as a fraction. So, oh, that's not nice. So, for example, we have the number 2. 2 can be expressed as a fraction. It's just 2 over 1. Basically, any whole number or any integer that you can think of can be expressed as a fraction as long as you throw it up over 1. So 2 over 1, -4, 7 over 3. We can also, and don't quite write this down, we can also put things like 0.3333333333 all the way out the door, I'm sure you guys have seen me do that. But the better way to express this is 3 with a bar on top. Any repeating decimal is still a rational number because it can be expressed as a fraction. Irrational numbers, those are my favorite. They're weird. They're numbers that cannot be expressed as a fraction. So we're talking about numbers like pi with like a bazillion digits after the 3 point. Bazillion is not a mathematical term. Just let you know that. I'm sure you know that already. 0.7387912 da 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 da. This number here is irrational because what's happening in these dot dot dots is more numbers. Okay, that what's happening in there just there are more and more and more numbers. It's a non-repeating decimal, so that means it's irrational. What about something like this? Square root of 3. What do you mean? It looks nice and contained. Well, let's see. If I would take the square root of 3, it's 1.73205087568877, and it goes on forever and ever and ever. That is also an irrational number because it goes on forever and ever without any sort of repeating. Real numbers, okay, they're all the numbers that we can actually imagine. That sounds very strange and cryptic, but basically any number that you can think of right now is a real number. The only thing that wouldn't be considered a real number is something called an imaginary number. Now, it feels like maybe I'm playing mind games with you. No, they're real numbers and imaginary numbers. But imaginary number system is based on the idea of I equaling the square root of -1. Okay, so real numbers, but you don't quite, well, maybe some people do, but in grade 9 in Manitoba, you aren't taught about imaginary numbers. So real numbers are all the numbers you can currently imagine. The numbers that exist. Oh. So if I were to make a Venn diagram of this thing, I would say all of the, I'm just going to make it so that it can all go on here. All of this box contains all of the real numbers. And remember that thing right there, that's the number sign. That just makes it so that I don't have to write numbers. It's not hashtag. It's not hashtag real. Or a messed up version of hashtag real. So let's start on the innermost, the smallest group of numbers. The smallest group of numbers are our natural numbers. They include 1, 2, 3, all the way up to the biggest number that you can imagine. Whole numbers are all of the natural numbers, but we're just adding 0. Okay, so 0, 1, 2, 3, 4. Integers. They include all the whole numbers, which include all of the natural numbers, but they have also negative numbers. So -3, -2, -1, and dot dot dots on this side. 0, 1, 2, 3, dot dot dot. Rational numbers are the next one that's out. So we have things like, okay, I don't want you to all of a sudden think that anything under a square root sign is an irrational number. So if I were to take the square root of 9, well, let's see what the square root of 9 is. Some of you might know what this is already, but if I say 9 square root, It's just 3. So that would be considered a rational number. 3 is just a rational number. Something like 2/3, even though it's 0.66666666 on forever, it can be expressed as a fraction, so we're okay. Something like 1.7, it's a decimal, but it terminates, okay? We can also have a negative decimal, so negative 4.3. Also can have a number like -2, which is just in the integers as well. Last but not least, I don't want to forget the irrational. They have nothing to do with the irrational, with the rationals. So there's no intersection between rational numbers and irrational numbers. It's kind of a binary. It's either or. So numbers like the square root of 2, pi, and 1.87326, not repeating, non-terminating. Questions that are going to pop up in the next section are going to be like, hey, what are all the different categories that these numbers fall into? So if I were to say -2, I would say it would fall under the rational category, and it also falls in the integer category. So the way that I think about it is, the first time that you see it in this kind of in the nested Venn diagram, if I would say, okay, what are all the things that 2 fits into? Okay, 2 fits into natural numbers, whole numbers, integers, rationals, and reals. It just does not fit into irrational. If I were to say something like, well, what are all the different categories that -2 can fit into? Well, it can fit into integers and rationals and reals, because natural and whole numbers do not include negative. So just make note to yourself, numbers can be in more than one category.